Hey everybody, this is Mrs. Kroll. These notes are going to go through section 4.5, which is going to be integration by substitution. We are going to start U substitution here, do some of the easier practice problems, and then the next time that we meet, we'll be going through some of the harder U substitution problems and finish up the section 4.5 notes. All right. So the first thing is, what is U substitution? All right, really, it's the reverse chain rule. Zoom in a little bit here for you so you can actually get a copy down. Now, this is directly from your book. All right. So we are going to be taking the antiderivative of a function inside of a function, so that we can end up having a u, and then that u allows us to take the antiderivative. Right? It becomes a pretty easy problem for the most part, so we can take the antiderivative, and then we can go ahead and we can just plug back in at the end whatever u was equal to. It is a really good idea to have two different colored highlighters or pens. I got two pens here that we're going to keep underlining and looking for things as we do the U substitution. All right, so this is, like I said, this is from the book, but there's some steps here as well that I like a little bit better than the definition from the book. So take a second to pause the video and copy it down. So start with choosing your u. So that's what you're looking for. Usually an inner part or something to the higher power part, or sometimes it's the denominator too. And we'll just practice so that way you can see them. We'll be practicing this a lot. Then find your du, which is going to be the derivative. Then we're going to rewrite the entire integral in terms of u and du. Then we can find the resulting integral or antiderivative. And then finally replace u with the original function to put the final answer back in terms of x. We always want it back in terms of x. And then check your answer. Okay, so here's our first problem that we're going to do together. And then I have a little spot over here for my u and my du. Since I know that it's going to be u substitution, I have that right there already. The other thing I notice is that this is an indefinite integral, meaning there's no numbers on the integral. So I won't be evaluating using the first fundamental theorem, but I will have to make sure I add plus c at the end since it's indefinite, and that's off the page. Sorry, add plus c. Okay. So the first thing that we're going to do is we're going to look for the inside piece. Whatever's on the inside, you're going to make that your u. So here on the inside, inside the squared, the whole function is squared. That inside piece is x squared plus 1. And so that's going to end up being my u. Now for du, we always take the derivative. It's asking for the derivative. So I'm going to go and bring down the 2x. And since it's the derivative, we're going to add on to this the derivative of x. So add on the dx. Now I can see my 2x dx is right here. So that's going to end up getting replaced with du. So when I rewrite this, the only thing that I'm left with is my integral is still there. Right? The part in the green now became u squared, and all of this underlined in red is going to be du. And so this is a pretty easy antiderivative to take. Add 1 to the power, so it's going to be u to the third divided by 3, or 1/3, times 1/3, plus c, because I took the antiderivative already. And then once you're done, you just don't want to have anything in terms of u. You want it all in terms of x. So wherever there was a u, we're going to fill back in with the u that we used originally to get an answer of 1/3 x squared plus 1 cubed plus c. And then if you wanted to do chain rule on this, that's fine. You can try chain rule off to the side. It will lead you right back to the integral that we were looking for. Okay, let's try another one. All right, so this next one has some trig in it. Most of the time, whenever we're doing trig, we always want to look at the inside of the trig. By looking at the inside of the trig, that if there's something other than x there, that's going to usually be our u. It won't always stay that way. Sometimes the trig functions will be our u. But since it's not just x in the inside, it's 5x, that's going to be my u. 5x. And when I take that derivative, it's going to be 5 dx, the derivative of u, to get my du. So that's this part here and that part over here. So I know anything lined up in red is going to become du. And then cosine is still in this of u du, because the u is the 5x. So that's going to be gone. So antiderivative of cosine is negative sine of u plus c. So I'm just going to go and fill in. Instead of u, I'm going to turn it into terms of x. So negative sine of 5x plus c for my final answer. All right, one last one that we're going to try. Now, there's a little bit more that we got to look at here. So we're going to start off, where's my inside piece? Well, inside everything to the third power is going to be this part. So that is going to be 5x squared plus 4. Now, when I take that derivative, it's going to be 10x dx. But when I look in my integral, oh, I don't want 10x dx. I'm only left with x dx in the integral. So I actually have too much here in my derivative. I have an extra constant that I don't want to actually have in the integral. And so I want to account for that. So what I'm going to do is I'm going to just kind of look at this like an equation. I want this to be equal to x dx so that I can substitute it in. And I'm going to end up substituting it in by dividing by 10 here. So I'm going to have 1/10 du. Sorry, that's a 1. So that when I rewrite this, I'm going to have the integral of this to the third, so u to the third, times 1/10 du. Well, I don't actually want this 1/10 in my integral at all. So remember, if it's a constant, we can bring it outside the integral. And so I'm going to bring that outside the integral and just multiply by 1/10 at the end. Now this integral is really easy. We're going to make it, or antiderivative I should say, is really easy. We're going to make it 1/4 u to the 4th power plus c times 1/10. So that's going to give me 1/40th. And I'm not going to use u anymore. I'm going to substitute it in. 5x squared plus 4 to the 4th power plus c. And so now by having that 1/40th in front, once I do my chain rule, that extra 10 that we'll have from the derivative of the inside ends up disappearing so that I'll get exactly the answer that was in the integral. The other thing a lot of people ask about is, well, why shouldn't this be 1/10 c? You distributed it in. Well, c is just a constant. So if I add to it, subtract from it, multiply, divide it, it doesn't matter. It's still always going to be c, because it's still 1/10 c, or c. It's going to still be a constant at the end, so we don't actually change that number at all. All right, we'll be working with this a lot more. If you have any questions at all, please reach out and let us know.